Today, we are going to give a quick overview on general systems theory. This week so far, we've discussed the difference between elemental, mechanistic understanding and systems-based understanding. The framework of what it means to know something has shifted in recent history, and that shift is a result of a field known as general systems theory, or GST. Here's a quote from one of the founders of GST, Ludwig von Bertalanffy. The necessity and feasibility of a systems approach became apparent only recently. Its necessity resulted from the fact that the mechanistic scheme of isolable causal trains and meristic treatment had proved insufficient to deal with theoretical problems, especially in the biosocial sciences and with the practical probiris posed by modern technology. Lots of big words there. But Bertalanffy is talking about how focusing on mechanisms when it comes to discovering things has proven insufficient for theoretical problems. And he notes that modern technology has really exacerbated this problem. When Bertalanffy is talking about modern technology here, he's saying this in 1968. Uh, so this notion that an elemental mechanistic framework for knowledge was a little outdated, this was being discussed as early as 1920. What Bertalanffy and the other founders of general systems theory created was a new paradigm for the development of theories. To quote Bertalanffy again, there exist models, principles, and laws that apply to generalized systems or their subclasses, irrespective of their particular kind, the nature of their component elements, and the relationships or forces between them. It seems legitimate to ask for a theory not of systems of a more or less special kind, but of universal principles applying to systems in general. Bertalanffy was a biologist by training, but he began to notice that physicists, chemists, economists, and social scientists were all coming up with new models for the phenomena in their respective fields. And those models all had similarities in their construct, even though they were all thought of independently of one another. He writes, there are correspondences in the principles that govern the behavior of entities that are intrinsically widely different. To take a simple example, an exponential law of growth applies to certain bacterial cells, to populations of bacteria, of animals or humans, and even to the progress of scientific research measured by the number of publications in genetics or science in general. The entities in question, such as bacteria, animals, men, books, etc., are completely different, and so are the causal mechanisms involved. Nevertheless, the mathematical law is the same. Bertalanffy published this paper in 1968 in the theory of systems, showing the theory of systems and its underlying mathematics. He and other contributors in the field had been discussing systems theory since the 1930s, but their ideas were met with skepticism for decades. And I love to point out that scientific developments are usually preceded by mathematical breakthroughs. It takes about half a century for the math to be accepted, digested, and then applied by scientists. So going back to Tuesday's video from this week, under the intellectual framework of systems, we can conclude things like trees communicate with one another, even though we do not know exactly how the mechanism works. Under this framework, we can see a tree as part of a system known as a forest. The tree can be in many ways confusing and enigmatic. However, we can learn things with certainty about the tree because it lives in a greater context. And by understanding the behavior of a system, like a forest, we can understand truths about the tree itself. One thing I really enjoy about this paper is that Bertalanffy takes time to address the social and moral implications of systems thinking. He provides a really interesting theory as to why we feel so powerless to make meaningful change in our modern society, which I'd recommend you check out. And he also writes on the dangers of humans being reduced to elements in a system, stripped of their individuality. He says, human society is not a community of ants or termites, governed by inherited instinct and controlled by the laws of the superordinate whole. It is based upon the achievements of the individual and is doomed if the individual is made a cog in the social machine. Powerful stuff. You can find Bertalanffy's 1968 paper, General Systems Theory, Foundations, Development, and Applications, online. And besides some big words and some old words, I would say that it's actually a pretty accessible read, the first two chapters at least. By chapter three, we are getting to the uppercase M math of systems theory. And that's likely going to be a little intimidating for people without an undergraduate mathematics education. But the rest of it, I would recommend checking out if you found this interesting. Ooh, oh boy. So I hope you found this overview of GST to be clear. And tomorrow I'm going to kick off a discussion on the nature of the self. The core question in the realm of spirituality is, who am I? And I am going to talk about this question in the framework of general systems theory. So, yeah, we'll get to that and I'll see you tomorrow.